Hi, it's so nice to see you. It's so nice to be at Swift Heroes. I'm so glad when I'm here today. And we are going to talk about green development. And it is a thing, at least as a concept in real estate development, which stands for the careful consideration of social and environmental impacts of the development, which is pretty cool, and I think it applies to any kind of development. So it applies to iOS development as well. And I think we're doing a pretty good job in terms of considering at least social impacts, because we care about privacy of our users, we care about security, we care about users which are not that represented and have uniqueness, their own uniqueness, and I think we always think about each particular user and their own experience with our apps and our products. So let's talk about, so we're talking about green development today because it's important nowadays. And I think it's coming to a time when we should start considering environmental impacts as well. To do so, I will just show you a simple logical chain how environmental impact, how your app can impact the environment. So let's think about, so you have an app on your phone and it drains the battery. So then battery drains, it comes to be discharged, and then you need to plug it to a charger. And then you plug it to a charger, it consumes electricity to power up the device. And then electricity is produced, emissions are produced as well. That's pretty simple. And what are these emissions? We always hear this scary word, and you don't really know what are they, why they affect the environment, and what's the problem with them. They are different. It's not only CO2, which is carbon dioxide, it's also methane and our greenhouse gases, which cause the planet to heat up. So their unique quality is that they can accumulate the heat, which causes the global warming. That's why we, as developers, we can do something about it. Because even if you think about devices in general, that is not only iPhones and others, they all consume electricity, and if we can reduce the amount we consume and consume sustainably, only the amount that we need, it will already improve the global picture a lot. So now we will talk about some numbers to get more into the topic. You know, there is also about the emissions, people always say that there are renewable energy and other ways to produce energy, but the most common way to produce electricity is by burning fossil fuels, so by the process of combustion of fossil fuels. And to obtain 1 kilowatt hour of energy, during that time, during the process of obtaining 1 kilowatt hour of energy, you will reject to the atmosphere 800 grams of CO2. And this is when you use the process of making electricity by burning fossil fuels. Remember this number for now, because now we will learn how much electricity does your iPhone consume. How much energy do you need to consume your iPhone? Do you know that number? Have you ever thought about it? That's pretty interesting. So if you are lucky enough and you have the iPhone 11 Pro Max, which has the biggest capacity of the battery, and it holds 3,500 mega ampere hours inside, so let's think, you have this device and you fully discharge it each day in the year and fully charge it overnight each day. So during the year, if we calculate, it will be something like 5.5 kilowatt hours per year. That's the amount of energy which you will need to have your iPhone fully charged every day. So this is a pretty low number. If you think about the money you pay for it, for example, it's something like 2 euros or 3 euros per year. So it's not too much. But you know how many iPhones are in use worldwide? It's 900 million iPhones in use worldwide. And this number was in January 2019. Now think about it. Think about it in scale. And If we, again, talk about numbers, and we think about a single person who have iPhone 11 Pro Max, and he needs 5.5 kilowatt hours of energy per year. So to the atmosphere, coming back to the CO2 and to the emissions, if the electricity that he used was produced by the combustion of fossil fuels, to the atmosphere for particularly his device will be released 4.4 kilograms of CO2. Now think about this 900 million of people. This is an average number. But not everybody have iPhone 11 Pro Max. And if you think about what is happening and why it's important to talk about this now, if you take iPhone 5, for example, it has twice less capacity of a battery. And each day we're trying, so all the companies which is producing phones, any phones, not only iPhones, we're trying to make the capacity of the battery bigger so we have more time to use our devices. And it's only getting bigger and bigger and bigger. So this number will only grow each time, and this is just the beginning of it. So it's all adds up. It's also, the charger also adds up there, because if you put it on a charger and you forget about it, charger also takes some energy. So what we can do about it, and how is it connected? We can save this energy. We can save this energy for our users, and which is really important here. Every time I speak to my friends about the global warming or the ecological problems that we're facing nowadays globally, they're all saying to me, okay, what can I do? I'm the only one. I can't do nothing. My reusable straw, reusable bag, or me sorting up this litter and rubbish what I have at home, it doesn't help me at all, and it doesn't help the planet because I saw nobody doing it. And if I drop this paper to recycling and others not, that will not change the picture. So you, all of you, you don't have this excuse because you're responsible and accountable for your users. So when you say, I'm the only one developer, you're not. Because you have your users. You might have only a few of them, but you might have hundreds and thousands and even millions maybe. But it comes with time. So you have this responsibility, and you can do something about it. And it's not that hard, especially coming with the new things that we have this year. But first, let's start with understanding how energy is used on your iPhone. There is no single solution. Thank you. I feel a little bit, woof, it's hot here. Okay, so there is no single solution when it comes to conserving energy on the device. So numerous things influences the way how energy is used on the iPhone. But first, let's talk about the main thing, which actually the most important thing which is in an iPhone. It is CPU. So the central processing unit is a major consumer of energy. You see how big is it on the screen? So the problem with CPU, so we always have this high periods of CPU, which I'll show a little bit later on the graph. And these high periods of CPU will rapidly drain users' battery. So the iPhone in general uses CPU for almost everything, but what it should do, because it should use the CPU, it should do it wisely by doing work only when it's needed, and by prioritizing the work which is needed to be done. So that's about the CPU. We also have device wake. So the iOS devices will rely on the sleep for the great battery use. But whenever the device wakes, it causes this high overhead cost as the screen and other resources must be powered up. So this is the graph that I wanted to show you. This is, so if you see the graph, all the part which is red, which is basically the cost of starting your hardware. And the green is all when the app is active. So you actually want to make all the greener part much smaller as you could do. And so the thing here is that, so we want to make this green part much smaller as it could be, and the overhead parts as less as possible, but you can't avoid them anyways. So also what happens when it also, loss of battery is drained is then when it comes to the networking, because networking has a high fixed cost in iOS. Whenever networking occurs, like when Wi-Fi must be power up and something, so you have this additional work, and then these resources remain running. When you don't need a network, you can just stop using it, and so when they keep running, they consume energy for the prolonged periods, even after your work is complete. So when you can just reduce this transaction, compress data, and handle the errors in a better way. You can make a significant contribution to, in general, to the energy conservation. So also very important and a big part of it is graphics, animations, and video. We all want to make our apps pretty and nice and user experience smooth, and I mean, in general, this is the most important part in any app, because you want it to look pretty and you want it to look nice. So, but every time your app's content updates on the screen, it uses energy to produce those pixels, every single pixel. So first, you can avoid updating the content when interface isn't visible to the user. Also, you can just use sometimes reduce image quality to make it more smooth. And then it comes also to location, because sometimes we need to log some physical activity and provide environment-based alerts, and this is just the examples. But the greater precision, energy use is only increasing, and makes location requests longer. So you can reduce accuracy whenever it's possible, and duration of location activity whenever possible, and then it will also contribute to energy conservation. Then it's also rarer calls, I would say, but motion, because sometimes you have this continuous unwanted request of accelerometer, gyroscope, magnetometer, and else. It is all waste energy. So then you can just stop the updates when it's no longer needed. Bluetooth, and obviously high periods of Bluetooth activity can drain the battery on the iOS device and Bluetooth device. So whenever possible, you can batch and buffer Bluetooth activity and reduce pooling for data. This is just the examples, because, you know, as I said from the start, there is no single way to explore everything. But iOS already has pretty much a lot of energy-saving techniques. We as iOS developers have it. We have integrated hardware and software. We have intelligent app management. We have network operation deferral. We have task prioritization. We have developer tools. And we will more talk about the last one today. And I think we should start with the background. So if we talk about the life of our app, we'll be talking about that particular one here. And these are all the things that can be happening in the background. There's pretty much things that can use background during the time user uses the app. And there are just typical things that can be how energy can be wasted in the background. You can not notify the system when background activity is complete. You can play silent audio. You can perform location updates. You can interracing with Bluetooth accessories, and you can also have some downloads that could be deferred, but they are not. So what can we do about it? First thing, we can complete background tasks. Yeah, this is obvious, but now we will talk about that a little bit more. So if you have just an example, if you have a messenger app and you usually just send a message, and the user expects this message to be sent immediately. So what we can do, if he just send a message and he just go to another app, or just shut up a phone and started a conversation with his friends in live, you should do it more. So you should protect the completion. because it could be that the network was not very good or something else happened, and so you can give the app an additional time to run in the background before being suspended. And you can also notify the user when if that wasn't completed, the user still wants it to be completed. So you can notify him, please resend the message. And now we will have a look at how can we do it. So this is some code for the background task completion. So what we're going to do, we're going to guard important tasks while app is still in the foreground. So, we want to just have this send operation. We want to send a message. So we create an identifier here. And so what we want to say that if our operation is successfully finished, is not finished, we need to notify the user, message not sent, please resend. And also, if it is finished, so we don't need it anymore, so you should probably end it and not notify the user about the errors. This is a nice thing to do. Should do it. Also, talking about the background, what can we do as well to save some energy? We can defer the background until a better time. So you have discretionary background URL session, so we configure a URL, we give some identifier, and then they create a session. Set it to the discretionary, and yeah, that's it. So what we can do here, so now we can set time intervals, we can create, we can set time windows and workload size. So what it means, now we can just set for how long you will set the time intervals, when you can create a request and set the time window, then you want a specific date when you want to download something, for example, at night, then the user has a connection or something else. And also you can expect how many bytes you want to receive and how many bytes you want to send, which is pretty cool what we can have at night right now. Yeah, so I think it's pretty useful in terms of what we have now, and it's pretty easy to include. So also there are lots of things in background which is have now. For example, background task framework. You can have a look for it more in advances in the background execution, WWDC 2019. It's a pretty good video. I really recommend everybody to watch it. We will not deep dive into that now. And now we will talk about the developer tools, what we have, to contribute to the energy conservation on the iPhones. So the most important thing, which I think applies to everything, not only to the development process, but in general to your life, is that if you can measure it, you can manage it. It's pretty simple and pretty useful. Even if you don't know how to start working on saving the energy, because saving energy is also improving the performance of your app a lot. And you know, it's really nice thing that every user now can go to the battery in settings and see this big list of apps which consumes energy. And you know, I deleted a couple of them because in the background they consume like enormous amount of energy, and I just deleted them because I don't need it, me as a user. So all other users can do it as well. So, and we can see, we can monitor energy uses in a debugger. It's been already there for quite some time, but this is the screen which you don't want to have, because you don't need this high energy impact. You need it to be like that. But if we just this, you can see in debug, if you go to the debug navigator in Xcode, like view navigator, show debug navigator, when you will see it all. And the energy gauss will provide live information about your app's energy use as it runs, and it will display a graph of recent energy related activity, which is pretty useful when you want to build something nice and which is performing great. So it's all pretty obvious, like it's all written there. Just play with it, try to improve your app as much as you can to get that kind of picture. Also, we have Xcode instruments for optimizations. And this is very great what we have now, because now we have okay, we had it, but we have text metrics. We have metric kit, which is really, really cool, and we have Xcode metrics organizer. These all tools provide you a good this is a good tool to make your app performance better. So, and it's pretty easy to adapt. This is just an example of metrics that you can collect. For example, this test will measure launch time. And this is very easy and nice and good to start doing. So, how we can adapt metric kit if we want to do it, to receive metrics. So you conform to the MX metric manager subscriber protocol, and you choose a place where you want to receive metrics. It's probably wise to do it in the app delegate because it's an entry point of your app. Well, so you have this singleton MX metrics manager, and you add a link to yourself. Yeah, here. And then we implement the method of a protocol to receive the metrics and the process them. So this is how it looks. And we can do actually something else. But please try to play with these instruments. There's not that much information about it yet, but we already talk about it today. If somebody of you been on the previous talk, we all learn, and then we can teach. And we all should learn about it to make a contribution. So, what else can we do better? There is a pretty cool thing which was launched this year. So together with iOS 13, we have low data mode. So we should adapt low data mode. This is a new feature which can be, so what it does in general, this mode can be enabled for any Wi-Fi or cellular connection. And what it does, it just singles the apps that they should be careful about how much data they use. So it might mean that you should just disable prefetching, or it might mean that you should use low-resolution images or some other ways, which will leads to cutting down the use of the data. So, but in general, anytime you can save the data, and there is no impact on the user's experience, you should always do it. This is just in general, Apple expects this from us, and it will be nice for the user as well. So, so for Apple in general, they suggest to at least adopt this mode for features that will have limited or no impact to the user experience, as I already said. So we just, let's have a look what way else what are the techniques that are suggested for confirming to the low data mode. So we can reduce image quality, as I already said. We can reduce prefetching. It's a really good technique for informing performance, but it has this downside as well, because you might end up fetching resources that user never needs. So also you can sync less often, usually using locally cached data more heavily. Thank you very much. Coming back to it. And also, we can mark background tasks as discretionary. We can disable autoplay, and also, which is very important, we should not block user-initiated work even if the low data mode is on, because user is perfectly aware that it's on, because they turn on the low data mode and they ask your application to perform this operation. So just go ahead and do it. And we can also do even more. There's also a nice thing which has been launched this year, which is, can you just imagine that always when you do when you write your code and you make your apps and you test them, you have a perfect conditions probably in your office. I hope so. I hope that you're all having a good good work environment. So you never think about that you probably could be that your user could be somewhere far away in the very cold city. You know, there is a city in Russia called Salihard. I've been there once. It's above the polar circle. And it's like -30 there or -45, which is pretty cold. You don't really feel it, it's all right, but it's very cold. Or you can be somewhere where it's very hot. I don't know, in a midsummer in Israel. It's very hot there at that time. And you don't think about it, but this year was introduced the device conditions. And this is a type of a screen which you don't want to get, and even if you have never got it yet, we are leading to the global warming. If we not contribute to it, you might see it more often. So let's think how we can work with it and what is it all about. Also about the device conditions. Sometimes the phone can just be heated up, then a user just doing like multitasking. I don't know, maybe sitting in a passenger seat in the car, playing music at the same time, playing some game, and also have this direction on the navigator, which can also lead the device to heat up, which will be pretty bad. Also, with the batteries in the device, they all actually can be damaged. You all faced this problem if you had a device for quite a long time, if you have an iPhone for quite a long time. I have mine for 2 years and it's already have these troubles with battery. So it's just because the heat damages the batteries. And it will be good if a user will know what it will be good to reduce it as much as possible, so you will save the money probably for the user, and it will be nice. So what actually damages the batteries and how they can be damaged? This hot temperature can cause permanent damage to the batteries, as far as I already said. They also have the indicator what can be affected by the heat, and they also, the chemical reactions, they will occur faster. It actually can, it will probably not bomb, like it happened to some companies, but it could be really, you can make you upset. So what we can do, we can save the battery. And we all want to be a hero. So now we have the new Xcode 11 tools for various temperatures. Let's talk about the thermal state conditions. So that's what's been released this year. You basically, let me just for a second go here. So you have thermal states, and this is basically how it looks. You have nominal state, fair, serious, and critical. And you can easily register for them. So what you can do, you register for thermal state change notifications, and you can now look which state the device reports to your app and consider scenarios with a normal, like device warming, because the system, and the system will know how to react to it and how to react to an increase in the temperature. So we have these device conditions. So in a nominal state, the device condition will be normal operating temperature at normal operating temperatures, and it will be no need to try to do any corrective actions in your app. The first state, Apple recommends you to proactively start some energy saving measures, so you will be not contributing significantly in the overall increase. Then the iOS sees thermal state fair. They start to pause. You can start to pause discretionary background work like photos analysis, for example. The serial thermal state comes. The system performance in that case will be impacted. So the app should start stronger energy saving measures, reduce heavy CPU if it's heavy CPU usage, graphics, and at this point you should use lower quality visual effects. For example, if you want, what could happen as well is that if the user, for example, just imagine the situation, he's restoring an iCloud backup or something, so they will find it that it will be paused at this state until the device cools down, which is very good for their iPhones. And then it's critical, your app should stop using everything, even like camera, and if you ending up on, for example, So everything like error key and FaceTime drop, FPS rate. So this is the state actions which will be. And how we can actually do it. How we can register for the process state, thermal state conditions. So we register for the process info, thermal state did change notification, and this is how that will look like. And then we go to, yeah, we go to, we create an enum where we switch from different thermal states what we have. And this is just an example what you can do. Yeah, but when it's critical, you should definitely just start panic. Disable user-first tracking and motion blur and everything what you have. Yeah. To sum up, even a small inefficiencies in your app, they add up. They significantly affecting battery life, performance, and the responsiveness of your app. So think about the background more. You already saw that today, you probably learned something more about it if you haven't heard about it yet. You can minimize networking whenever it's possible. You can measure as much as possible, so you can manage it later. It's all important and it all starts right now with little single changes. And I want to remind you again that you have this power, you have the responsibility for your users, and the great power comes great responsibility. So you have an obligation to make sure that your app runs as efficiently as it's possible. And just to sum up, here's some further links. This is a really, really good article about low data mode, how you can adapt it in your app by Donny Walls. He actually has a birthday today. You can also congratulate him if you will have a look. This is some WWDC videos which I recommend to watch. And also this is really nice energy efficiency guides for iOS apps where you can find almost everything. Was a little bit outdated, but everything that you can find about the energy gauges and all that stuff is very, very good. Thank you very much for your attention.